Good afternoon, and first of all, I would like to thank Giovanni for organizing this great event and making this all here possible. So I feel a little bit like something like a stranger here. You're all talking a lot about the details in healthcare, and I'm more centered on how one small piece of technology could help you in your work. And I hope I can bring you some insights in our work and our methods, and maybe find some use of it. So, since a lot of you asked me yesterday where exactly St. Poelten, the place of my university, is, I brought a small map. It's very close to Vienna, and yeah, now you know. We're a small and young university of applied sciences with a few programs going from media technology to healthcare studies like nursing and dietology, and are well equipped with a lot of laboratories, for example, electronics, usability, TV, and audio. But now, let's go to the stuff which I'm really coming here to talk about, visual analytics. Why do we need it? Because lots of data, mountains of data. I will not use the word with B, but there is a lot of data in electronic health records, a lot of data from sensors, a lot of data from knowledge bases, and also business data. And of course, we do not just want to collect the data for the sake of it. We want to make some use of it. We want to get insights out of the data and use these insights to learn about the phenomena in the real world that are just mapped by the data. And we also want to make predictions and use the data for helping us taking decisions. So, what can we do? Well, there is a lot of theories how to come up to decisions and so on, make predictions, statistics, machine learning, and so on, and so on, and so on. But in the end, it boils down that you need some integrated approaches. If you just put statistics on a problem, you might not find what you're actually looking for, but you might only find what you were asking, what kind of hypothesis you take, and similar problems with data mining approaches as well. So then again, you can say, okay, so I'll just have a look at the data and look at the next data and the next data. But usually data is too large to look at it one by one in details, even though there are some approaches to optimize to compress data quite well. So we propose one possible way to tackle these wide challenges of the mountains of data, and we call our field of work visual analytics. Usually it's defined as the science of analytical reasoning facilitated by interactive visual interfaces, but I would just like to make this word a little bit more concrete and explain it in my own words. So visual analytics is a method to perform tasks involving data, and for this using a combination of both computer-based analysis systems and human judgment. And this combination of computer-based analysis and of human judgment is facilitated by indirect interactions. So people are supposed to have some direct access to the data via computers and visual representations of the data. Visual representations like charts, but charts that you can directly interact with. I will show you some examples later. Now talking about visual analytics for healthcare, data in particular, it boiled down for me to something like 5 main challenges, for which I would like to also show you some examples. First of all, we think that we observed that time is very present in many analysis problems, and in particular also in healthcare data, in the electronic health record. You do have, for example, if patients improving or patient condition declining over time. You have medical procedures applied one after another, also with the temporal interval in between these conditions having possibly as an important role. So as I said, there is a lot of time-oriented stuff like laboratories, and yeah, to make it more complex, there are of course multiple. They are sampled irregularly. For example, I worked in a project with diabetes outpatient clinic, and there we had some patients that came every month to visit the clinic, and other patients who had good management of their diabetes, they just had to arrive like twice a year. So it's if you take you couldn't just take a regular like daily or a second sampling by second for this data. Furthermore, there were different granularities or levels of detail for the data to analyze, and also different time primitives. For example, instantaneous instantaneously measured lab tests, and interval data for patient treatment. And also there is the problem of temporal indeterminacy, so that sometimes you have you know that something happened, but you cannot place this information precisely on the time scale. So my colleagues, Wolfgang Eigner and so on, looked very much into the details of time-oriented data and collected these 7 + 6 different criteria of all, just to show you how complex it can be to work with time-oriented data. And we followed up this theoretical work with building a software library to support some of the aspects like multiple granularities, cycler patterns, different time primitives, and allowing us to prototype visualization and visual analytics systems with this. Now, let me come to the more, now that we laid the foundation with time-oriented data, we can put something like healthcare specific challenges. First of all, there is the challenge to intertwine the patient conditions with treatment processes. So, for example, you don't have just time series of lab results, but also applying the therapies. Maybe here in this case we had the diabetes project, where you had on the one hand lab results, but also in the very bottom you see the insulin therapy. And with these intervals of course you have to consider that intervals of therapy can overlap. So this is something that you would not expect if you just had instantaneous sequences. Another project, the Care Cruiser, which I cannot go into much detail because of the time. This allows you to map patient conditions and improvements or decline in relation to clinical guidelines and protocol, which you see in the overview on the left. And the third challenge is to go not only from a single patient, but to take the scale on from a single patient to patient cohorts, or maybe, as we hear today, to whole populations of patients. And here, yeah, it just gets bigger data and more need to focus. For example, here in the project Gravi++, there was a mapping used. You can see here these 6 blocks on the border are something like magnets. And in the center, you see the colored circles, which are the patients of the cohort. And the blocks represent variables, drawing the patients towards them. And by manipulating the variables, you could see how different patterns in the cohort exist. It's like patients having a strong value in one group of variables were drawn more in these directions. Another approach was in the life flow project, where you had where they started off with data like you see it on the left side, patients arriving in the hospital, being in the emergency department, and then being discharged alive. And they had like lots of patients, all showing the same pattern, and they collapsed this sequence view on the left to a view like in the right, and arriving at a much better overview, which you can see here. Third one is data quality and data uncertainty. I think we had it already a lot of times in this workshop, and I will just give you a few examples of work we've done here. Here is some work in time series imputation, which is not so specialized, which was not specialized in e-health, but yeah, time series can of course be in a lot of medical parameters. And here we used approach to, we had this time series with a clear seasonal pattern, and that was applied. As we can see here, we took out the seasonal pattern and then which then allows people, human judgment, as I said before in the definition, to judge different recommendations given by the statistical methods. So here's another view of which allows you to show uncertainty in a medical plan, like in a guideline that has a earliest possible start and latest possible start and so on. And let me, before I finish, just give the fifth and most important challenge is probably involving the users. Thank God we have a lot of specialists also here and talks that focused on the problems of adoption, on the problems of evaluation, user-centered design. One point I would love to pick out in particular is interaction, which is, it's part of my definition of visual analytics. So it's necessary to, it's typical for a visual analytics project that you interactively engage with the data through visual means. And so in this diabetes project we designed such a system, and then when we showed it to doctors, yeah, they couldn't really fit it into the workflow, because they rather wanted a system to see medical data at a glance. So again, we had to go back to user-centered design, draw back, give them some view on a glance, and kept the interaction possibilities for other groups of users. And since then, we used these prototypes on a lot of different data, from climate to economical data, and have this so to summarize, we have defined visual analytics as a method to analyze data using a combination of human judgment and automated data analysis. And we have these visual representations and direct interaction with this representation as a means to facilitate between them. Thank you for your attention.
Thank you very much. I have to excuse my